Hi class, I'm going to do a quick demonstration on how to calculate heart rate using your EKG form. Shown down here, I have drawn an R to R bracket here, and I want you to remember that the squares are 5 by 5. So if I count how many squares I have, that's 5, 10, 15, 20 millimeters, plus there's one more extra one over here, so that's 21. And then 2 extra lines over here, that would be 23. So one beat was 23 millimeters for an R to R. Then I multiply by the paper speed, and depending on your exam version, do not assume a paper speed, we will give it to you. But let's say the paper speed is 20 millimeters per second. You can see that the millimeters would cancel out and I'd be left with beats over second. Then I can convert seconds into minute, and for this particular R to R, it was 52 beats per minute. That's very different than what the machine told us for this heart rate for this individual. However, we can see if I had chosen a different R to R, this one was only 17 millimeters, and that would give me a very different heart rate. So the machine took an average of all of these R to Rs, and that's how it came up with that higher number. On your exam, I will be giving you a picture of just one R to R, so you can't pick which one you're going to be using. You will need to count the boxes and the little dots inside. Again, each box is a 5 by 5 millimeter. So you can count the millimeters going across. Then multiply by paper speed and then convert to beats per minute. The next thing I want to show you is the visual trick on how to calculate MEA. First of all, here are the 6 leads drawn in a circle for each of the 6 that you need to know. I've paired them appropriately because when you use the visual trick, the fact is you can use any 2 leads you want to use. However, if you pick 2 leads where if you use them together, they would cut your circle into a perfect quadrant, it's more powerful. On the exam, I will pick the 2 leads you use. It will be one of these 3 sets. You might be asked to use lead 1 in AVF, or lead 2 in AVL, or lead 3 in AVR. I will ask you to use the visual trick in both a forward and a backward fashion. What does forward mean? First of all, if I tell you which 2 leads you're using, and I tell you if there's an upward or positive deflection or downward or negative deflection for those leads. For example, let's say I choose lead 1 and AVF for you. If I tell you lead 1 was overall positive and lead AVF was overall negative, what you do is you draw your circle, you draw lead 1. Then you shade in the half of the circle that would represent the positive side of lead 1. Do the same in another circle for AVF. AVF, we're told, is negative. So I shaded in the half of the circle that reflects the negative side of AVF. Then draw another circle and look at the overlap of the shading that you did in each individual circle. Where there is overlap, that is where your person's MEA is. In this example, it's suggestive of a left axial deviation. But what about going backward? Well, in this case, I tell you where the person's MEA is. For example, I might say a person has a right axial deviation. Then I'll ask you, would this be a positive or a negative deflection? And I again will pick two leads. In this example, I'm asking you if a person has a right axial deviation, will it be a negative or positive deflection for lead 2? Will it be a positive or negative deflection for lead AVL? Here's how you do these steps. Number 1, draw a circle with the leads in it that you were told to use. Number 2, draw the overlap. So here are my leads drawn in. Here's AVL in lead 2. We're told it's a right axial deviation. This is where it's your job to know roughly the degrees for that. A right axial deviation would be equal to or higher than 110 degrees. So it's roughly in this area. Now step 3, which end of the lead does the overlap fall on? Well, clearly for AVL, it's on the negative side of AVL. So that would be a negative deflection. For lead 2, it is on the positive side of lead 2. So that would be an upward or positive deflection. Now, I'm going to give you a rough overview of what to expect. I'll just focus on my anatomy models here while I talk to you about what to expect on your EKG exam. Depending on your instructor, your EKG exam can be about, well, for mine's a little bit longer, but I have roughly 36 possible points. It will be graded out of 35. The first 30 questions are multiple choice. The questions that are multiple choice, it is very important that you look at the first 2 pages of your Unit 3 homework packet, as those give questions very similar to what you would expect on your actual EKG exam. Also on Canvas, you have been practicing with an EKG quiz and a cardiac cycle quiz. All of those would be very helpful. The cardiac cycle lecture is also very helpful to review for this EKG exam. Your instructor might include what we call the cardiac beast on the exam. You should check with your own instructor to find out if this is the case. For the street classes, you will not have the beast on your EKG exam. You can expect the the cardiac cycle beast from the cardiac cycle lecture to be on lecture exam 3. The multiple choice questions will basically ask you about isovolumic relaxation, isovolumic contraction. When do the ventricles actually eject blood? What must happen? I'll remind you that valves open and close because of pressure differences. Blood also moves from high pressure to low. So this explains why we see filling of the ventricles, but also ejection of the ventricles. Please, when you take your quiz or your exam, make sure you read the question carefully. It's easy to confuse atrial versus aortic, and I see students interchanging those. If I use the word atrial, I'm asking about something that's happening in the atria. If I say aortic, then I'm asking about pressure in the aorta. You should also know what EDV is and what determines it, what ESV is and what determines it. Again, that came from the cardiac cycle lecture. and also what influences stroke volume. Please remember that a first-degree AV nodal block would be a PR interval longer than 0.2 seconds. Be aware of your intervals and segments. The PR interval reflects the amount of time required for the atria to depolarize and also the delay at the AV node. The PR segment is the delay at the AV node only. Please also review that there are 2 places where a delay actually occurs to allow the atria to have their electrical event followed by a mechanical event. There will be a multiple choice section, a matching section of the different intervals, segments, QRS complex, and match them to their descriptions. You can find the descriptions on 2 slides within the EKG lecture, where I go through all of those electrical events and tell you what they represent electrically and what mechanical event will occur. Also on the multiple choice part, this is where you will be asked to do the visual trick for determining an MEA, both in a forward fashion and backward, as I said. And you should also review why we see, if it's a bundle branch block, if it's a left bundle branch, why do you see the MEA point to the side where the bundle branch is blocked? So what does that mean electrically? What does an MEA for a right bundle branch block look like? What does that represent electrically? Remember, vectors point to area of positive surface charge. And when do we see a positive surface charge? At rest and repolarization. So if there is a bundle branch block, then that means on that side of the heart, the cells will be at rest longer wait to get the action potential. We also know that we have different we have a different system for depolarization in the atria versus ventricles. We acted this out in class, and I suggest that you review that. I also talked about the IV septum and how the IV septum depolarizes differently on the right side versus left. Also, understand how the deep breathing of when we held the breath in versus held the breath out and what that did to the MEA. There's also a matching section for the electrolyte disorders. The 6 of them total, 3 hypos, 3 hypers. And again, I ask you to match those 6 electrolyte disorders to the descriptions that you can find on 2 slides in the EKG. This comes just before the visual trick demonstration in the EKG lecture. You will also have 5 points where you will tell me if the pen will go up or down for our vector analysis, and we practice that. If I give you a lead and I show you a cardiac vector right next to it, can you tell me if the pen will go up or down? Then lastly, there will be a free response. I will give you an EKG. You will need to count the boxes. Again, I have to give you the paper speed. Don't assume a paper speed. It could be 20 millimeters per second. It could be 25 millimeters per second. It could be 40 millimeters per second, but I will give you a paper speed. In the free response box, you are going to calculate the person's heart rate. Again, you're going to have to count boxes because each of you on your computer screen might have a different size computer screen, so you will have to count boxes. I will also ask you to calculate a segment or an interval. It will be your job to know where you begin that measurement and where you end it. Again, you will have to count boxes. You will not be using a ruler on your computer screen. And again, it will be a free response where you're going to calculate in the free response box your segment or interval that I give you. Then lastly, you're going to calculate someone's MEA using a compass. This is where I'm going to give you an EKG picture, and you are going to use one of the compass pictures and take a picture of it and send it to me to my cell phone, or you're going to send it to me through email, and I will hand grade that. I will be supplying a picture of the EKG compass for you to print on Canvas. So calculating heart rate will be worth 2 points. Calculating an interval or segment will be worth 2 points. And calculating MEA will also be worth 2 points. And you should remember the units for all 3 of those. All right, this concludes our overview of your EKG exam.